Hello, my name is Roy Simpson, and this lecture is on intermediate algebra, algebraic expressions. This is part one of a series about algebraic expressions. In this part, we're going to focus on the order of operations. This is more of a review for intermediate algebra, so we're not actually into an intermediate algebra topic here. This is more of arithmetic and elementary algebra. But still, I think it's very important that people get good with this stuff because obviously you can't do any algebra unless you know the order of operations and what an algebraic expression is and how to build algebraic expressions from word problems. So the prerequisites for at least this part, being the order of operations, is the ability to do arithmetic. Now, the order of operations, a lot of people know it as PEMDAS, P-E-M-D-A-S. And that's just a simple way to remember kind of how you focus on performing some mathematics using a specific recipe or an order of operations. The P generally stands for parentheses, but specifically we'll focus on the innermost parentheses. And also, a couple things to note here since we're in intermediate algebra or you're in a trig course or something like that. You should note that often parentheses can be disguised as in other forms. So this could also be like square roots, absolute value signs, things like this. And as I have written here, it's basically any container symbol. So you're looking for the innermost container. Right. The next one is kind of misnamed. It's named exponents, just like parentheses is misnamed a little bit because obviously there can be square roots and absolute values. E, standing for exponents, being the second thing that you worry about, is not really true because while it is true that square roots are exponents, there are other things that can be run at the same time. So I generally just call this the machine step. And what I mean by this is, let's say, for example, that you have something like 3 times the absolute value of 2 minus 5. Following PEMDAS, we would say, okay, let's hop in this container and do the math in here first. So 2 minus 5, you would get a negative 3. Now, often what PEMDAS leaves off is that you have to actually allow that absolute value to do its business now. So before we do anything else, then this exponents step, I just say it's the machine step. If everything's done inside this machine, let the machine run. So that becomes a 3 times a positive 3. So, because the absolute value of a negative number makes it a positive. It's 3 times 3 becomes 9. Okay, so that's what I mean by let the machines run. And in this lecture and future lectures, I will always refer to that step as the machine or basically the machine step. The next two steps are often linked together. It's the multiplication division step. And essentially, if you have a big expression with a bunch of numbers, and all it contains is multiplications and divisions, you perform these from left to right. And that's very, very, very important. If you don't perform this multiplication division step from left to right, you're guaranteed to get some answers wrong. Finally, you have these last two, the A and the S, and that's the addition and subtraction step. And again, this is done from left to right. Now, a lot of people often just kind of eat this up and go, okay, well, I guess that's what I'll always do. And they never really understand why the order of operations is built the way it is. And I can't guarantee I'll ever be able to explain exactly why. However, let me sort of justify it by maybe talking briefly about it. So why do we follow the order of operations? So first, I'm going to ask you to agree with me on a few things here. First thing is that addition and subtraction are the quote-unquote easiest operations. Now, I say easiest because, in quotes there, because it turns out while they are somewhat easy to do when it's just like 3 plus 5 or 7 minus 18 or something like that, they actually end up being some of the worst operations we've ever learned. It turns out that addition and subtraction, and I'll often say it in my lectures, addition and subtraction are the worst operations that we have. But they are actually the easiest, but they still are the worst operations we have. And that, if you watch a lot of my lectures, you'll see I harp on that a lot. The second thing is that multiplication is just repeated addition. If we can all agree with that, you know that 3 times 5 means 3 plus 3 plus 3 plus 3 plus 3, right? Add 3 to itself 5 times. So it's just repeated addition. And division is actually repeated subtraction. 15 divided by 3 means 15 minus 3 minus 3 minus 3 minus 3 minus 3 until you get to 0. Okay, so it is a shortcut to subtraction. So these are slightly more complex than addition or subtraction. Third thing I think we should all agree upon is that raising a number to a power, like 5 to the 10th power, is just repeated multiplication. 5 times 5 times 5 times 5 10 times. But remember, multiplication is just repeated addition. So that is basically a repeated addition. Right? You're adding 5 to itself a bunch of times. Okay, so it's even more complex than multiplication and division. So essentially what the order of operations says is, let's start with, first of all, the innermost group. Well, that I can't explain away. But it says start with the most difficult thing. And in my opinion, once we've talked about this, like addition and subtraction being the easiest, multiplication, division being the next level up as far as difficulty, and then raising numbers to powers even more complex than that. Well, PEMDAS takes care of exponents, then it takes care of multiplication, division, then it goes to addition and subtraction. So PEMDAS starts hard and goes to the easy. So PEMDAS goes from complex to easy. And that means that you just take care of the most complex operations and work your way down. So let's see what this looks like when we try some examples. 5 times the quantity 3 minus 5 over 2 minus 18 over a negative 3. Now remember, PEMDAS, the first thing we need to do is look at all the containers. And a fraction bar actually is a division of containers itself even. So in a fraction bar you have a container on top and a container on the denominator as well. So the denominator is considered a container and the numerator is considered a container. So what we need to do is focus in on each numerator as its own problem and each denominator as its own problem, and so on and so forth. Well, let's just write down the denominators and numerators that are already cleaned up. Whoops, that wasn't a negative 18 up there. Sorry about that. So these things are already as simple as possible. This numerator is already simple, this denominator is already simple, and so on and so forth. But the numerator on the first fraction here is not so simple yet. We have this innermost parenthesis here. So let's do the math in there. Are there any exponents on the inside of it? No, I'll highlight it actually. We're looking at this step right here. Are there any exponents? No machines, no exponents, nothing like that. No multiplication, no division, but only the subtraction, right? So 3 minus 5, that gives me the negative 2. And there we go. Now, again, that's still very complex compared to the other numerators and denominators. So I'll rewrite the other numerators and denominators again. 2 minus an 18 over a negative 3. And in this step, the innermost parenthesis, there's nothing to do. So once there's nothing to do on the innermost parenthesis, we go ahead and highlight the next outermost container, which is just the 5 times the negative 2. And we perform that multiplication. Because again, there are no exponents, so we just perform that multiplication. And at this point, each of these containers, this numerator, this denominator, this numerator, this denominator, they're all cleaned up. So our next step really is to go to addition, or is to go to exponents to see if there are any exponents in this entire thing. There isn't. Multiplication, division, and there is. A fraction bar implies division, so we'll go ahead and do this division now that we've cleaned things up. So negative 10 divided by 2 is going to be a negative 5 minus, and then this one has an 18 divided by a negative 3, which is going to be a negative 6. So I look at this and I say, okay, PEMDAS, parentheses, the innermost parentheses is at negative 6, but there really is nothing to do inside there. I look for exponents. There's no exponents. I look for multiplication, division. Technically, negative times negative is a multiplication, so I'll clean that up. And now I see I just have addition left. I have a negative 5 plus 6, which is just a positive 1. So let's go ahead and try another one. And in this example, this is fairly typical of an example that will trip most students up who are really bad with the order of operations. So we'll look at PEMDAS here. We'll say, okay, start with the parentheses step. We'll go to the innermost parentheses. So you start, it's like an onion. You start peeling off outer layers until you get to this innermost layer. And you perform the mathematics in there. So everything else I'm just going to rewrite. 27 divided by the quantity 3 times the quantity 9 minus 3 times the quantity, we don't know what that is yet, and quantity, and quantity. Well, 4 minus 2, that's pretty easy. That's just 2. All right, so now I take a look at this and I go, okay, what are the, again, following PEMDAS, are there any innermost parentheses? There sure are. Technically, this 2 is the innermost parentheses, but there's nothing to do in there, so I'll highlight the next set of innermost. So that's the next group of math things I'm going to do, next expression I'm going to deal with. So we have 27 divided by the quantity, 3 times something, and quantity. That's something. Let's see, in here, are there any exponents? Nope, no exponents. Multiplication and division. Yes, there is. Now here's where a lot of students will fall apart. They actually do this subtraction first. They go, oh, 9 minus 3, that's 6. That's the simplest operation, so that should be held off until last. You should really be focusing on the negative 3 times the positive 2 there. That gives you a negative 6. Okay, so 3 times 2 is 6. It has a negative in front of it. We still have some work on this innermost parenthesis, the 9 minus 6 now. So this is equal to 27 divided by the quantity 3 times, well, 9 minus 6, we know what that is. It's just 3. Pretty easy. Now our next step, again, innermost parentheses, there's just a 3, so there's nothing else to do with that. So let's kind of zoom out a little bit to this group of parentheses and pay attention to the math there. It's just multiplication. There's no addition, subtraction, nothing else. So this will be just 27 divided by 3 times 3, which is 9. Now notice I didn't write any parentheses or anything because there's really no need to. At this point, I mean, writing 27 divided by 9 is the same thing as writing 27 divided by the quantity of 9. It's just, it's more ink. That's all. In this last step, there's nothing left but a division, so write that out as 3. Now, let me show you something really quickly on how to perform these steps using a calculator. If you have a graphing calculator, then you essentially just type it in as you see it. 27 divided by, start a parenthesis, 3, start a parenthesis, 9 minus 3, start a parenthesis, 4 minus 2, and the parenthesis, and the parenthesis, and the parenthesis. What this tells the calculator is, listen, go to the innermost parentheses. Sorry about that. Go to the innermost parenthesis and do the subtraction, 4 minus 2. Then when you're done, go to the next innermost parenthesis, and so on and so forth. So the calculator is going to do all this stuff like we did. And when I hit enter here, you'll see we get 3. You should be able to do this stuff by hand, though, because if you can't do it by hand, you'll likely fail whatever exam you're taking, and you should fail whatever exam you're taking. Sounds cruel, but there it is. As a final example on using the order of operations, we have some stuff with powers here. And remember, everything's fractions make containers, right? We have a numerator that's container, a denominator that's container. We have another container over here. So when you have an addition that is between two mathematical operations there, you can split it up into two separate problems if you want. So I could focus on just doing one at a time, or I could do the left fraction and the right power at the same time. Well, what I'm going to do is actually take my time and just focus on this leftmost item first. So I'll be very slow about this, even though I don't really need to be. Okay, so we have up in this uppermost numerator here, we have a multiplication and an exponent, but exponents go first. So that's going to be 4 times 9. And now I see in this numerator up here, it's just a multiplication, so that's going to be 36 up there. 6 is still downstairs, and we still have the 3 times 4 squared here. And I should look at this parenthesis now, because I would be breaking the order of operations if I went any further, actually. So let me go ahead and just rewrite that and simplify this other expression. Remember, innermost parentheses, so I'll deal with that 3 times 4 first. So let me highlight that. I could have done this earlier, but I just saved it, that's all. So we have a 12 being squared. And now, remember exponents before this division or anything else. So 12 squared is 144. Finally, we have an addition and we have a division. Division is more complex, so it runs first. 36 divided by 6. And now we'll finish up with addition. All right, 150. Now there is something else I want to kind of mention before I end this video. Let's try to use a calculator here to simplify the square root of 27 squared plus 36 squared. I love this problem because, well, I get a lot of students that love to do this. They like to say, oh, that's equal to, and I'm going to put a little question mark above it and ask you. They like to say, well, the square root of 27 squared is just 27, and the square root of 36 squared is just 36. So most students hope that this is going to be 5063. Well, let's grab a calculator and find out. Let's see, we have the square root, so second square root, of 27 squared plus 36 squared in the parentheses. Oh, it's 45. So what happened? What's the difference? So this equals 45. So why is that number different than that 63? Well, the reason why it's different is because the order of operations. If you follow the order of operations, the square root itself is a container. So I'm going to hop inside there and do some math. So I have to do that math before I can do anything with the square root. So I'm going to find out what 27 squared is. I'll go ahead and grab a handy dandy calculator for that. So 27 squared is 729. And 36 squared is 1,296. And of course, this I still have to work on the inside of the square root, because again, the square root is a container. I have to clean up the inside of the container before I can allow that machine to run. So let's go ahead and add up 729 plus 1296. 2,025. And of course the square root, not of course, but now that we've cleaned up the inside, we can take the square root of that, and that will actually be 45. So the problem over here doing this thing, which is absolutely wrong, is that what we did is we said, oh, well, I don't want to clean up the inside first. I'd rather just let the square root run first, which is breaking the order of operations. Remember, you work on the inside, clean up the inside as much as possible, and then you can, once everything's cleaned up, you can run that square root. Now, this is where I start telling my students often that addition and subtraction are the worst operations in the world. What you generally want to be true is not true. For example, 3 plus 4 squared. I have a lot of students that would love to see this as 3 squared plus 4 squared. However, 3 squared is 9, 4 squared is 16, and that would be 25. The problem that I know about that is 3 plus 4 is 7. And when you square that, that's supposed to be 49. So I know this way is correct. This way is not correct. This is absolutely the incorrect way to go. But we love to split things up like that. We always love to split parentheses and square roots when we see additions, and you can't do it. So whatever you want to do with addition or subtraction, forget about it. It generally doesn't work out.